Hi, welcome to our session on why nobody buys your product because it runs on Kubernetes. My name is Aaron Erickson. I am an independent consultant who is very focused on internal developer platforms. And today we're going to talk about how using internal developer platforms to get your project started quickly and eliminate infrastructure will help you sleep better at night. This is about empowering your engineers to do the best work of their careers. So a lot of us have been in this situation where we have an idea on Sunday night and we just can't sleep very well at all. We're just thinking about it all night. And so we want to get ready first thing Monday morning and start working on the idea. We're really, really excited about what we can make. And then we get to work Monday morning, and instead of writing code about that algorithm or that new way that we're going to use machine learning to do something amazing, we're gonna, oh man, we gotta set up a bunch of things. We need to set up Visual Studio Code, and what about my Docker container? I got the service mesh thing, and oh, the password needs to go in a vault. There's all these things that we need to do to set up just to get to the first line of code that is about your product, not about infrastructure. And in a lot of organizations, this becomes just almost impossible to get past, and you lose your momentum. Oh, now we got to work on the afternoon. We're still not done. We still can't write any product code yet. We have a back-end database to worry about. We have to pick a front-end framework. We have to kind of figure out, are we going to use some kind of gRPC library? How do we get Kafka figured out? I want to use some language that maybe is standard or maybe a little bit less standard. All these different things. Maybe I need observability capabilities to from the beginning, but we're still not done even with just the setup. And what we find is we've spent an entire day just looking at technologies. It feels very Sisyphean. It feels very much like you're pushing a boulder up a hill, and it really just kind of impacts your productivity. You lose momentum. And what happens in a lot of cases, unless you're really, really dedicated, the idea dies. You just don't have the momentum to get it through. Maybe you don't have the time. Maybe you have other work responsibilities. And so your idea doesn't see the light of day. And that's tragic. That is absolutely tragic. I lament how many ideas die because it was just too daunting to get started. And sometimes it may be a day. I've seen organizations where it can take 6 weeks just to get a developer environment and infrastructure. So one of the things that's happening in the industry broadly is organizations are building internal developer platforms. What's an internal developer platform? Well, here's the idea of what you would do with it. Step one, you pick a type of service that you want to develop. It could be, what language is it going to be? What cloud provider are you going to use? So forth. You then click a button, and then things happen on the back end, and then you start writing code. That helps solve the customer problem. You don't have to fiddle with a bunch of infrastructure. It's amazing. One of the ways I like to frame this is there's all this technology out there. But let's really kind of answer the question, how many really important decisions are you making when you're setting up this stuff? And granted, there are a few. You probably need to figure out what language you are. You probably need to have an opinion about your continuous delivery system. You do need to think about what cloud provider you're going to run on and so forth. But imagine for most services that you run that there are a good set of baseline decisions that work for almost all of these tools. And in most organizations, that actually exists. In fact, in a lot of organizations, there are standards for which of these things you're going to do. There's a lot of organizations where, no, we're running this on AWS. That's who we have a relationship with. That decision's been made for you. Having to use HashiCorp Vault is a decision many organizations it's baked in. You can't use something else. So we can automate a lot of these things, or at least take out the kind of cognitive load of having to make all these decisions. So really what happens if you have a good baseline, there's actually not many at all. There can be 0 important decisions that you're actually making at the time that you're building that. So then why are you having to onboard onto all this stuff individually if that is in fact true? So what I like to think about is creating a golden path, creating a very easy way for you to get on board and get started working on your product. You might want to go off and do something a little bit different, but for the most part, if you stay on this path of whatever the internal developer platform has and the set of decisions that you standardize on, you can be up and running and productive in minutes or hours in the worst case. What I'm really here to do, and this is kind of something I'm really passionate about at an industry level, is automating all the cruft. I just want to program. I just want to write code. I want to build my product. That is what I want to do. So, yes, my new band name, Smart Defaults and the Golden Path. What I think works really well is when you can pick a series of good defaults that work for most things based on your stack, your requirements, some small set of default sets, and then have most of your projects created using those defaults. Simple. So what happens when you're not using those defaults? What happens when everybody kind of does this on their own? Well, this is somebody made a graphical representation of what many microservice architectures look like. I think this is one of the big tech companies where all the dots might be services and all the lines are connections between all the services. Imagine a world where you have thousands of services and each configuration of each service is slightly different. Now, maybe that's needed, but it usually isn't. What you really end up with when you do this by mistake is you end up with what I like to call snowflakes. Snowflake services, congratulations. So I think most of us that have been around the DevOps world for some years and think about how to do infrastructure in a modern way, we know what Snowflake servers are. But have you heard of Snowflake services? Well, they're every service with a slightly different configuration. We have an entire industry around things like observability and stuff where a lot of the time is spent figuring out what these minor differences are and remediating things around them. But when you put one of these kinds of systems together, it's funny when you talk to a mechanical engineer that looks at a kind of microservice architecture as it tends to exist in the industry. They are terrified. They have a name for this, and we call it the microservice-based self-operating napkin. Or another, so as you can see in the picture, there's way too many moving parts, a lot of just kind of cruft to make the thing work. We also call this in mechanical engineering a Rube Goldberg design because of the amount of extra moving parts, which create every single one of those connections is a place where you can have errors. It's a place where you can have something break. There will be, in this industry, work pretty much forever. Fixing broken microservice architectures due to the tyranny of accidental differences is going to be a growth industry for the next 20 years. I guarantee it. So how do internal developer platforms help? Well, one of the things that I like to think they do is it reduces what I call accidental configuration drift. Generally speaking, if you have 1,000 services in your estate of services in a digital organization, you're going to have, if you have 5 container configurations, maybe one for front end, maybe one for kind of RESTful services, maybe one special kind for machine learning that runs on GPUs, so forth. But if you can reduce that, if you can get that to some small number, it might be 5, maybe 10, that's going to be more maintainable than 500 or 1,000, where every single service is going to run slightly differently. One of the other things we like to be able to do when we're setting these up is to make a lot of the interactions between services work in a more predictable manner using things like common libraries. So for example, you might decide you want to talk to, say you're using Kafka. You want to talk to Kafka in a very similar way across your entire suite of maybe Java services that you're running or whatever language they happen to be in. If everybody's kind of doing their own way they connect to those kind of common elements, that again creates an opportunity for new kinds of issues to emerge in a system, or when there's a cross-cutting concern that has to be fixed, now you have to fix it in every single slightly different library. The other thing this really kind of helps with, if you can standardize on these things, is onboarding time. So what you want in terms of differences from one code base to the next are not infrastructure differences unless you really need them. It should be differences in what the product does. Most of the infrastructure certain differences, with some exceptions, there are some good reasons, but they're a lot fewer than most people think. Having to do with infrastructure, most of the differences should be based on the product, what it does, what value it adds for a customer. It doesn't mean you can't screw up even using one of these things. And some of the things I've seen in the industry that you still have to watch out for, these things still cause some issues, are not doing good microservice architecture. Things like using a central database as an integration point. None of this will fix that as a problem. Say for example, you have Kafka format, Kafka message formats that differ in ways that are not predictable, and that you have a downstream consumer that breaks. There's still ways you can break things. There is this implicit coupling or accidental coupling between what kind of look like on the surface unrelated services. There's also just kind of dumb integration. So a naive microservice implementation might have 4, 5, 6 hops between the front end and the back end. And if every one of those hops is a REST call with bad latency, I've seen cases where somebody was developing locally, but then they go to production and suddenly just loading up the page takes 30 minutes because they didn't really kind of think through how these interfaces work. So, that's just kind of an obvious example, but there's a lot of dumb integration cases when in some of these systems. The other thing is what I call the cost spiral problem, which is a lot of times people will not understand the cost implications of choices they are making. So you just kind of bring services in, you migrate, you do a lift and shift, and then you run everything on expensive instances. Maybe you're not using auto scaling well, maybe you're not using spot instances on AWS where you can, and so forth, which can have the bad effect of your system becoming basically a good way for Amazon to make money and not you. What you want is for the ability to, for all the services in your organization and for the standard way that they're configured to be something that you can plan for in the creation of it, so that if you want to then later on maybe change how they run to cost optimize, it gives you a leverage point to do that. The other thing I have observed in years doing this stuff is studies show that being tired is the same as being drunk. And so I always like to ask the question, do you like having drunk engineers on call? Is that great? Having systems that break all the time tend to leave you with that. There is sometimes a lot of industry advice that talks about service ownership as always inherently good. And I actually think as a concept, it's great. But I think there's some things where we've taken some basic practices, but then kind of abused and taken them a little bit too far. One of them, I like to think, I call it the anti-pattern of heroic service ownership, which means it is seen as a good thing. You're a hero in the organization. If you wake up at 3 a.m., PagerDuty calls you, and you have to fix the system. Having that as a condition means there is a bug in your system and you need to fix that right away. Internal developer platforms can help you create a world where that's not the thing, but that's definitely a problem. Which is a version of another problem I've seen, which is when you have SRE embedded in teams. Well, wait a second. Why aren't we just designing reliable systems in the first place? If we have to actually have as a function somebody that's going to be on call all the time and always having to be the person that knows how to fix a thing, that's usually an outcome that is the result of a bunch of bad decisions that have happened in the past. And so what you really need to do is fix the reliability of the car in this analogy, not try to design a reliability around the car. And then, when you think about how internal developer platforms can help, much of the reliability problems go away when there's just fewer accidental differences in how standard services run on standard infrastructure. I actually have strong conviction that if you get the number of ways that services run down to a much smaller number and standardize on that, standardize on some libraries, you can actually resolve a lot of what often are the kinds of incidents that happen in big complex architectures. Yes, of course, there are always exceptions. If you have lots of implicit coupling, or if you just are bad at writing code and have systems that break because you don't have sufficient testing in your pipeline, this doesn't solve that. Engineering still matters, but at least in terms of how things run on infrastructure, this using a system like this eliminates a vast, percentage of the kinds of problems that you're going to have. So I actually believe that using a platform like this, using an internal developer platform, will drive better reliability outcomes in addition to solving for some cost, in addition to helping you get products out the door faster. So how do we get this reliability by internal platform? Well, we do things like network configuration by default has redundancy built in. We do things like having standard Kafka libraries that are able to handle intermittent outages in those kinds of systems. And I've seen these kinds of things work really well. You might have just standard logging and observability that, when you create this the right way, creates your alerts in the right manner, gets everything going to the right central place in a kind of consistent way. So you have to set it up a whole bunch of times independently. And then, you can say, okay, well, whenever I deploy, every single thing is set up to be running in multiple availability zones, regions, so forth. You can standardize on that and have the internal platform enforce those kinds of constraints. And then really this kind of applies to any other kind of cross-cutting reliability concern. There's all sorts of other things you can do, like with service mesh and so forth, that can either add redundancy or add better failure modes to systems that will really kind of help achieve the reliability that we're talking about. So how do you make this happen? Well, I saw this problem a number of years ago when I was at Salesforce, and we were having some struggles with this, and me and a group of people decided we'd fix it. And so we did. We built our own internal developer platform, and there was lots of overcoming, but people want to use something different. What does this do for autonomy? Engineers want access directly to AWS console. So obviously a concern and something we had to be able to answer. Lots of worrying about, for good reasons, what I like to call opaque abstractions, where if you need to do something special in one part of the pipeline, you don't want the platform to stop you from doing that. You need an ability to what I call off-road or do something slightly different when you need to go off the golden path. Now, the funny thing is, though, I noticed as people started using the system that we built, that there were actually, most people didn't. Most people found that they could work within the standard constraints, and they had a strong motivation to not do it, because anything you built, any kind of off-roading you would end up having to support. It was usually easier to kind of just not do that stuff if you didn't want to or didn't really need it. And then, of course, especially given where we were, there's always people that, hey, why can't I just use Heroku? One of these exists. And I think if Heroku works for you, you should use it. Or if any other platform that's a little more standard like that works, you should use it. But a lot of organizations have some workflows that aren't handled in that use case. One example is every time we did a new deployment, we need to have a security review. It was a legal constraint, which to build that into the platform isn't a standard workflow in a tool like that. So things like that, or you might have more complex infrastructure requirements than can be handled in that standard way. So that's a lot of the reasons why people will roll their own if there isn't like a standard way they can do it. And of course, there's still some problems being solved in this industry. One of the things I think we had was there were a bunch of existing services. We want to migrate them in. It's a little bit of a harder problem, because there might be some other kinds of dependencies. You might not be able to necessarily have it run in the standard model. It may have different dependencies on the way mesh works or the way secrets work. So there's kind of a lot of manual work to do a migration. None of that's automated yet, but you can still migrate. It's going to be some work. There are new products that are coming out in this space that I love that it's happening. I mean, this wasn't really considered a product category until maybe even in the last 12 months, but GitHub Actions is one feature within GitHub that you can use to do this. I remember when I first saw Backstage.io, the product, I talked to my team, I said, wow, somebody has an open source project doing a lot of what we were doing in Salesforce. And then the last one, and it's one that I'm really excited about, is there's a new startup in Germany called Humanitech, and they are building internal developer platform products. They didn't pay me to say that. I'm just really impressed by what I've seen, and really am excited that this is actually happening. So, some takeaways, some things to remember. No customer ever bought your product because you run on Kubernetes really well. No customer cares about Kubernetes unless they are buying Kubernetes. So, writing all that extra code is not stuff that doesn't create customer value. You may have to do it. There may be a thing you have to do, but it's not. It shouldn't be your primary focus. Another way I like to think about this is every task that gets in the way of starting building something, being able to get to production with your first idea. Everything gets in the way of that will reduce the number of ideas that move through the organization. It reduces the conversion rate of idea to at least something that can be shown to maybe a product leader that might decide to fund your idea. That I want to get more ideas funded, and I don't want to put walls up to that happening. And then, this is a key one, but every slight unintentional difference in how a service runs is a long-term tax on your company that your successors will pay for in sleepless nights. If there's one thing you get out of this, it's tired engineers are as bad as drunk engineers. And we don't want drunk engineers doing work on our system. We want them to sleep it off, come back in the morning and fix it then. And I think if we can get away from this world where we're constantly on pager duty, constantly just always responding to issues and being reactive, I think the industry in general will be a lot better off. And then getting to that reliability point. Reliability at the platform level is always better than reliability at the service level every time. And make sure you solve for both. You do not want to be that company that is not able to make progress on its roadmap a few years in because you're constantly responding to issues. That is a tax on productivity in the company, and it is not something that will enable you to compete. Most of this stuff applies for ops teams. Imagine a world where you can use a platform like this to do things like automated patching or other kinds of standard operational tasks that, by the way, get a lot better the more you standardize within your internal platform. Really, really important thing. It's probably its own talk. This is a developer productivity conference, so we're not going to talk about ops productivity, but there is an entire lane of ops productivity as well that applies here. Thank you. I really appreciate everybody watching this. And if you have questions, please reach out to me, aaron.c.erickson@gmail.com, or at my Twitter handle at @AaronErickson. Thank you.